Another topic in the chapter of force is center of gravity. This is an easy topic, and then all that you have in this topic is to understand what is the center of gravity, and then to know where does the center of gravity lie for different shapes. So let's understand the topic of center of gravity. Center of gravity for a body of mass is defined as it's a point about which the summation of all the weights of the particles is zero. So let's understand this. For example, take this irregular shaped object, and then if I think of this irregular shaped objects as small pieces consisting of small particles, and then each particle would weigh some amount. For example, if the entire body is 1 kg, and if I make it 100 kg, 100 parts, then each part would weigh 10 grams, isn't it? So I can do that. So this body, I can imagine this entire body as consisted of system of particles. So individual particles will make up the entire body. So each particle weighs some weight. So let's say the weight of all the particles in the body are W1, W2, W3, W4, and so on and so forth. And then I define a point in the entire body, let's say here, this point, and then if I calculate the movement of each weight about this point, and if that sum of all the weights is equal to 0 about this point, that point is called center of gravity. It's slightly difficult to understand as far as the concept is concerned, but practical implications when you see, you will easily understand it. So all that it says is, for example, the entire weight can be considered to act at the point. So another way of understanding is, if I take a body and yes, this body weighs 10 kg, and if I ask you where does the weight actually concentrated on, the weight is concentrated at this particular point. If you could say, that would actually make the analysis is easy. So to make it easier, we need to define a concept called center of gravity, and the center of gravity is exactly a point in the body where you can really assume that the entire weight is concentrated. So it is a point also of balance. For example, if it is the center of gravity, and then you can actually balance the body about that point. So if you had seen a book is there, if I put it, I can balance the book at the center on my finger, because when I place my finger exactly at the center of gravity, the book would be balanced. Any other point, the book does not balance. So it's also a point of balance. Center of gravity, very important point. It depends upon the shape. That means it depends upon the distribution of mass. For example, if I take this body, and then the center of mass of the body is here, and then if I add a particular weight at this point, where does my center of gravity, next new center of gravity lie? My new center of gravity moves towards this point, and it will shift towards here. So the center of gravity depends upon the shape or the distribution of the mass. So if the mass is now, instead of being added here, and if I add the mass here, then my new center of gravity would move here. So the center of gravity is always towards the more mass. Wherever you have more mass, that is where you have the center of gravity. It will be closer to it. Some of the applications of this concept are, for example, in double-decker buses, if you see the center of gravity for a single bus, the center of gravity is here. If you have a double-decker bus, the center of gravity is somewhere here. So whenever the center of gravity of any body is above the ground, far above the ground, then that body is not stable. So what people will do is, they say, not too many people should not get into the upper deck. Rather, first fill the lower deck, and only then go to the upper deck. Otherwise, it will become unstable. So another important example of the center of gravity is, if you have seen the cranes. So whenever you are lifting a weight with the crane, if you observe in the base, large big stones are put. Because usually the center of gravity of the stone would be, the center of gravity of the crane is at the top, because this is where all our weights, we are lifting weights here. So the center of gravity is at the top. So if the center of gravity is at the top, so this is unstable. So that is why it will become unstable. To make it stable, move the center of gravity down by adding big stone blocks at the down. The other very important example is, if you see the race cars are made very flat. The race cars are made very flat. This is because if the car is flat, that means center of gravity is closer to the ground, and then even when it travels faster, it does not easily topple over. So the center of gravity is a very important concept, especially when the objects needs to be balanced. The center of gravity depends only on the shape or the distribution of the mass. So by adjusting the mass in the body, you can actually shift the position of the center of gravity, and we have seen here how that principle is exploited to our advantage in cranes, and also in double-decker buses, and also in race cars. Sometimes the center of gravity does not necessarily lie only within the material. It can also lie outside the material. For example, if you see a ring, in a ring, the center of gravity is in the center of the ring where there is no material. So if this is my ring, the center of gravity is inside the ring. So there is no material here, but the center of gravity is assumed to be here. So there are some shapes, important shapes in your syllabus, about which you need to know where the center of gravity lies. For example, if it is a straight line, and then the center of gravity is exactly at the midpoint of the straight line. And if I have a circular rod, the center of gravity lies on the axis of the rod, but exactly at the midpoint on the axis of the rod. So on the axis of the rod, but midpoint of the axis of the rod. And then in a triangle, where does the center of gravity of a triangle lie? It is at the intersection of the medians. Important, very important. At the intersection of the medians. This is one median, that is a line joining the vertex to the center of the midpoint of the other side. This is called a median. Vertex to the midpoint of the next opposite side, median. So it is another median. So three medians, wherever they intersect, that point is called the center of gravity for a triangle. Where does the center of gravity of a square or a rectangle or a rhombus or a parallelogram of any of these things will be there. So for all these four objects or shapes, the center of gravity will be at the intersection of diagonals. It is at the intersection of the diagonals. So the intersection of the diagonals will directly give you the position of the center of gravity. If it is a circular ring, if it is a circular plate, so at the geometric center of the circle, this is the center of gravity. Or if it is a sphere, solid sphere, or a hollow sphere, it is at the geometric center of the solid sphere, geometric center of the hollow sphere. If it is a cone, which is a solid cone, then the center of gravity is on the axis of the cone, but at a height h by 4 from the base. From the base at a distance of h by 4, it is there. And then if the cone is instead of solid, it is hollow, then it is at a distance of h by 3 from the base, and again the center of gravity lies on the axis of the cone. So that's all you need to know about the center of gravity.